Can we do number 11 on 6.6?
6.6. That's fine. That's good enough. 11 on 6.6. 11. So we have this scenario in which I have the notation I have to keep as is. I'm given 120 degrees. I'm given 10 here and 18 here. And the question is, solve the triangle ABC. Now for this triangle, it doesn't tell us what to do. So let's write both. Let's just write, right? So what I don't have is side C, correct? What I don't have is angle A, and what I don't have also is angle B, correct? So let's say we start with law of sines, right? Then I will write sine of 120 degrees divided by C equals sine angle A divided by 18 and equals sine angle B divided by 10. And I'm in big trouble because I can't do anything. Look at this proportion. I don't have these two. So if I multiply them, cross multiply, I won't get anything just because I have two variables in one proportion. If I use this two, I have the same problem. Two variables in one proportion. If I use these two, I have the same problem. Two variables in one proportion. So the law of sines is not the way to go here. So now let's find, and let's write the law of cosines for C, because I have A, I have lowercase b, and I have lowercase a.
C squared.
Yes.
Equals A squared plus B squared.
Yes.
Minus 2AB.
Yes.
Cosine C. Cosine C.
Exactly. Good. So then C will be the square root. I will not put plus or minus, right? A squared, which is this, 18 squared plus b squared, which is 10 squared, minus 2 times 18 and times 10 times cosine 120 degrees. That's all I need. Nothing, really. So let's go to, oops, I just plugged it in. So go to the graphing calculator. In one step, do not work on these calculations. Oops, I didn't mean that. I meant this. Okay, so the square root, you know I have to put parentheses. You know me already. 18 squared, and then plus 10 squared, and then minus 2 times 18 times 10. I could have written 180 to be exact. And times cosine of 120 degrees, which I can determine by hand, but it's okay. Close the parenthesis. Before you hit enter, I have to check what? Yes, I have to check the mode. Very good. So it's in radians, so I'm not going to get anything. So I have to change it into degrees because I used an angle in degrees. So now I'm ready to press enter, and that will be side C, 24.6 roughly. So I'm going back. C equals approximately 24.6. Very good. So now I can continue applying law of cosines if I want to, or I can go back to law of sines. Now I can, because I have C. So if you look at this proportion, I have C, which is this piece, and I can cross multiply to get sine A. So I will write sine A equals 18 times sine 120 divided by 24.6. Because I have this piece now. I can cross multiply. Yes?
Can you show how to find like that angle through law of cosine?
Yes.
Yeah, because that's what I was trying to do, and I just kept getting like.
Yeah, that's fine. Yes, of course. So then you have to write 18 squared equals 10 squared plus 24.6 squared minus 2 times 10 times 24.6 times cosine A.
So you can do it either way and still get the same.
Of course, absolutely. You can use a method, I can use a different method, we'll have to get the same answer. So I'll show you with both, okay? So remember with cosine, this will be easier than this, only because I have to move this term to this side, I have to move this term to this side and divide by whole thing. So cosine A will be 10 squared plus 24.6 squared minus 18 squared divided by 2 times 10 times 24.6. Because I have to solve for cosine. So now let's plug in the graphing calculator. I'm going to plug in both so I can show you that angle A will be the same, no matter which avenue you take. So 18 times sine 120 and divide the whole thing by 24.6. So I get this. So this is sine A. So now I go to second and sine inverse of the previous answer. And I want an angle, and the angle will be in degrees or radians, of course. So I press enter, and I got for A roughly 39 degrees. So now with the other formula, with cosine, I will get parentheses 10 squared plus 100 plus 24.6 squared minus minus 18 squared. Sorry, I was looking at something else. Close the parenthesis, divided by, in parentheses, 20 times 24.6, close the parenthesis. So whatever I get, blah, fine. You know that they have to add up to 1, right? Okay. Anyway, so fine. So now I go to second and cosine inverse of the previous answer. And what should the answer be?
39.
Right. It may be a little bit of an error because I used 24.6 as an approximation. I didn't use the exact.
Okay, yeah, okay, that makes sense. Because I wasn't bringing that over and doing all that.
So from here, I have A equals 39 degrees. That's why I said, please redo the problems we do in class first.
I didn't have my laptop.
Okay. Good. Anything else from this section before we look at war problems? Anything else you worked on?
Okay, I have a whole piece of homework for you.
Yes, I'm ready. We either do that or we pick other problems. That's
Oh,
fine.
no,
Either way.
come on.
Either way.
Like questions.
Yeah, I had one from the homework actually, going back to one of the ones we just did to start class.
Yes?
It was, so the problem is sine inverse, and then in parentheses sine positive 17 pi over 6.
70 pi over 6?
Yeah.
And the question is, what is that?
Yes.
Right. So I am tempted to say, well, I apply the inverse function to the function, right?
Right.
These two are inverse functions. And what does that mean? If I apply the inverse function and then the function, I should get x. If I apply the function and then the inverse, I should just get x. So I am tempted to write 17 pi over 6. But that would be incorrect. Because I know the answer for sine has to be between this point and this point. Between negative pi over 2 and pi over 2. And this is not an angle between negative pi over 2 and pi over 2. So I could not write this. But what I can do is find sine 17 pi over 6. So 17 multiplied by 30 is 430. 510, I'm sorry. 1 and 2, right? 510. So 510 degrees, where is 510? So this is 360, plus another 360 will be past that. So I subtract 360 from it, and I get 150. So the angle is this. So that's the angle 17 pi over 6. Starts here and ends here. So 17 pi over 6. Any questions on that?
Where did you pull the 30 from?
Pi over 6. That we cannot. Pi over 6, we know it's 30. So then 17 pi over 6, we know it ends in the second quadrant, right? So how much is sine 17 pi over 6 then? What is the reference angle?
5%.
Right. So how much is sine pi over 6?
I don't know.
It's the first number at the top of the little chart that we have to remember. 1/2. So this number is 1/2. So now I'm really asked to find sine inverse of 1/2. And I will have to give an answer somewhere here. It has to be an angle between 0 and pi over 2. That's it. So I could not blindly say sine inverse will kill this because the answer was not between negative pi over 2 and pi over 2. Very good. Next question. Anything else you worked on? Anything else you'd like to see?
Yeah, I saw a question mark.
Yes.
Looks like it was on 6.2 over 55.
Yes, 6.2. So you said 55 on 6.2? Perfect. Let's take a look.
Oh, yeah, yeah.
6.2. 55. 6.3, 6.2, and you said 55? 55. We did 54 in class for that reason. Can you still think about that? Before that, so just think about it for a minute, and I would like to look at a word problem. 51 on 482. Okay? Cable car is the problem. Here's a cable car. It goes from this point to the top of a mountain. And let's see what we are given. A steep mountain is inclined 74 degrees right here. That's the inclination right here. That's the angle. To the horizontal, right? And rises, as we see, 3,400 feet above the surrounding plain. Fine. A cable car is to be installed from a point 800 feet from the base of the top of the mountain. From the base to the top of the mountain, sorry, as shown. Find the shortest length of cable needed. So I'm going to copy the figure right here. So we're asked to find x, and this is 74 degrees, and we have 800 feet here. And we have 3,400 feet here. That's it. Find the shortest length of cable needed, which is find the length x. Any suggestions on this?
Can we find that angle?
Yes, excellent. What is it?
Oh, that one is 180 minus 74.
Good.
186.
Good.
Yeah.
Good. So I have this piece. I have this angle. Is there any way I can determine this piece? And if the answer is yes, what does this piece represent for this triangle, and how do I find it? Exactly. Excellent. Yes? I'm going to call this y. How do I find y? Yeah? No, it's right triangle. I'm not saying it's wrong. I'm not saying it's wrong, but it's too more that you are making it difficult.
Oh, well, it has an angle at the top.
I have this, and I want to find that. So there must be something that we learned 2 weeks ago that will give us that. Very good. Sine 74 degrees equals 3,400 divided by y. Cross multiply, y equals 3,400 divided by sine 74 degrees. Very good. So let's determine y. So 3,400. Are we in agreement with this, everyone?
Yeah.
Perfect. Perfect. Divided by sine 74 degrees. Close. And I got 3537. 3537. So y 3537. Good. So now what happens next?
Now we know that, can we use a cosine?
Yes.
Cosine 160.
So how do I write it now?
From a law of cosine?
Of course.
Okay, so we need, what's gonna be x squared?
Exactly.
Equals 800 squared plus 37 squared minus 2, 800 times 35 times 2 cosine of 106.
Excellent. And take the square root from that. And it's done. See how useful law of cosines is? Of course, this is right here. It continues, but I didn't have room. Clear? So, I will put the square root already because I want everything in one step. So I have 800 squared plus 3537 squared minus 1600. I already multiplied 2 by 800 times 3537 times cosine 120. No, 106. 106, close the parenthesis for cosine and close the parenthesis for the under the square root, and I press enter and I got 3835.4 feet. So approximately the cable has to be 3835.8 feet. Any questions? I want to refresh your memory onto the formulas. That's 3. And then I want to add one more. And then I would like to review more. Okay. So if I have this triangle, it's not a right triangle, any triangle. And let's say I have the height, and I have this, which is the base. What is the area of this triangle?
1/2 base times by 8.
Very good. So the base times the height divided by 2. Excellent. Or you can write it as you said, Jane, 1/2 times 8 times 8. It's the same thing. Okay, we also know another formula. But this time, so for this, I have to have the base and the height. But now let's say we are given two sides, like side A and side C, and we are given the angle in between those two sides. We discussed this some time ago. I want to review this with you. What will be the area of this triangle? It's still the base times height, but the height will be function of this angle. So it's still A times C times sine B divided by 2, because the height now is the opposite over C. And then from there we determined a few times ago, last week, 2 weeks ago, we determined that H is nothing else but C times sine B. So that's another situation. But remember, I'm going to circle what has to be given. Here I have to be given these two, and here I have to be given these 3. A, C, and the angle in between. Now there is a third option. Here's a third option. I have a triangle whose sides are given. So all sides are given, A, C, and B. How do I determine the area of this triangle? Well, there is another formula. You will find the formula on page somewhere in your book in 6.6. I don't need it right now, but anyway. So here's the formula. I'll tell you where it is. A is very clear. It's the side labeled A. B is side labeled B, and C side labeled C. But what is S? It's 1/2 of the perimeter. So what has to give in this situation? These have to be given in this situation. So I have three possibilities. If I'm given the base and the height, we use the same formula we know for ages. If I'm given two sides and the angle in between, I can use this formula. And if I'm given all three sides, I can use this formula. So I like to practice one example here. So find the area of the triangle whose sides have the given length. On page 481, please choose 29 through 32. So we can practice this. Okay, I will, if you don't want to. 32. On page 481. We are given A equals 11, B equals 100, and C equals 101. I'm asked to find the area. I will have to find the semi-perimeter right away. 11 plus 100 plus 101. 11 plus 100 plus 11, 101, I'm sorry, is 201 plus 11 is 212. Divided by 2 is 106. So then the area of this triangle will be the square root of 106 times 106 minus 11 times 106 minus 100 times 106 minus 101. I don't have to put all these parentheses in the calculator because that's really not a big deal. This is 6, this is 5, and this is 95. Okay, so these are the numbers I'm going to put in the calculator. So I don't have to mess with so many parentheses. So the square root of parentheses only for the outside, 106 multiplied by 95 multiplied by 6 and multiplied by 5. I could have said multiplied by 30, same thing. And I get 549.6. 549.6 squared units, whatever the units are, because this is area. So 549.6 squared units. And this formula bears Heron's name. So here it is. It's on page 479, where S is the semi-perimeter of the triangle, so half of the perimeter. So we calculate half, and that's formula. All three formulas are very useful for determining the area of a triangle, depending on what you're given. So if you're being given base and height, if you're given two sides and the angle in between, or if you're given all three sides. The triangle can be anything. It doesn't have to be a right triangle. Good. So is there anything else you think we should review in 6.6? Are there other questions from 6.6? I want to go back to 6.5. Let's look at word problem from there. The flight of a plane, distance across a river, distance across the lake, so it's the same thing. Height of a tree. Any preference? No preference? I'm on page 474. Page 474. We did not get the chance to practice or look at word problems with law of sines. Any preference? Okay, let's see the flight of a plane. So 34 on page 474. A pilot is flying over a straight highway. Okay, so here's the highway and here's the plane somewhere. He determines the angle of depression to 2 mileposts. So a milepost here and a milepost here, and here's the plane. Don't ask me to draw a plane, I'm sorry. So he determines the angle of depression to this milepost This is the angle of depression. Remember the idea. So from the eye level up, level of elevation, angle of elevation, and from the eye level down, angle of depression. Angle of depression and elevation, okay? Yes? So 32 degrees, is it a yes or a no? Okay, and 48 degrees. And we are told that the distance here is 5 miles between the mileposts. Fine. Find the distance of the plane from point A. Find the elevation of the plane. Here, this will be the elevation of the plane. So this is, I'm going to call it y. And this, the distance from post A, I'm going to call it A. We're trying to determine the distance between the airplane and milepost A, and also the altitude at which the plane is flying. Any suggestions? Okay. Okay, so if you do law of sines, so you're going to say then, so I have to denote this by a letter. What is this? Okay, perfect. Then what is this? Okay, perfect. That's fine. How much is x plus t? 5 miles. Good, we have that. Good. So we know that this angle is 32. Maybe we can determine this angle. Exactly. Absolutely. Alternate interior angles. Very good. Formed by two parallel lines. Excellent. Good.
The other one's 48.
Okay, very good. So then this one is 48 degrees. Perfect. Good. So far, so good. Anything else? Okay, so let's look at this triangle and later look at this triangle. Can we determine x from here? And you can say, wait a minute, the question is asking us to find a. The problem is asking us to find a and find y. True, but I have 2 variables in there, and I have to involve 5 because I have 2 variables in one triangle, right? So let's see what we can do. So can I identify x from here? Think in terms of trigonometry, not only squaring and Pythagorean theorem and so on and so forth. If I use sine, then I will involve y, and I will involve a, and I have 2 variables, and I will not get x. I only want to involve one of the 2 variables, not both. Okay, if you want cosine, that's possible, and I will involve a. Okay, so let's start on that. I would have preferred to say tangent. Here's why. If I say tangent 32, what do I get? Careful. Y over x. Good. Let's come back here. Yes, I can take x from here, cross multiplying, so x equals y over tangent 32. Good. So now from the other triangle, I want to find y. I'm sorry. Very good. Tangent 48 degrees is what? Y over t. So therefore t will be y divided by tangent 48. Now what do you think I'm going to do next? So I have this piece in terms of y. I have this piece in terms of y. And I also have their sum. So what?
Y over tangent 32 degrees plus y.
Exactly. I'm going to plug them in because I have an equation. And now I have only one variable. Which variable? I still have. Exactly. Exactly. So then I have y divided by tangent 32 degrees plus y divided by tangent 48 degrees equals 5. I finally created an equation that has only one variable. This I know how to solve. How should I solve it? How do I proceed? Nope. I'm solving for y. What would be my next step? Remember, there are two key words in math. I shouldn't say just two.
Factor
Simplify. Which one it is now? No, I can't. Exactly. What will I factor? Of course. 1 over tangent 32. These are just numbers. I don't want to mess with them till the very end. And finally, how do I get y? Which operation I have to perform now to get y by itself? Divide. By what by what?
Divide 1 divided by 10 to 32. Everything in the parentheses. And divided by 5.
The other way around.
Or the other way. 5 divided
Because
by
it's y multiplied by something.
Yeah.
I need to get rid of that something. So which operation do I perform? Division by what?
just 5.
Exactly. Very good. Excellent. Don't bother with that. Just put the whole thing in the graphing calculator. There's no point in doing anything else. So 5, there is no need for parentheses for the top, divided by, in parentheses, 1 divided by tangent 32 is 32, yes. Close the parenthesis, and then plus 1 divided by tangent, and that is 48. Close the parenthesis for the denominator, and I'm done. So I found the height of the plane, the altitude. I'm going to say roughly 2. So I'm going to say y is approximately 2 miles. Good. So now coming back to my graph, can I determine the distance between the plane and a milepost A? Yes, because I have y. And now I can determine x. Look here. I can find x in a blink. Have x because I have y. So then x equals 2 divided by tangent 32. Or you simply apply sine. You don't even have to do this. You can apply, because you have y, you can apply sine 32 degrees equals y over a. And from there you find a. Either this or the other one. So sine 32 degrees equals y, which is 2, divided by a. Cross multiply. A equals 2 over sine 32 degrees. And that will give us, we didn't even need to apply law of sines. Why? Because they were right triangles. Is it wrong to apply law of sines? No, of course not. So 2 divided by, we were not specifically told you have to apply law of sines. You apply whatever you want, what is easier for you. So 32, close the parenthesis and press enter, and it's 3.8. So approximately the distance between the plane and milepost A is roughly 3.8 miles.
So when you think x equals 2 divided by 10 to 32?
If you want to go that route, you don't have to.
Yeah, the answer kind of varies a little bit.
Oh, yeah, let's take a look.
It's still weird.
No, it can't. It can't. It can't. So x equals 2 over tangent 32. Just a minor error because of the approximation, because I used here 2 miles instead of 1.99999.
Yeah, that's what I was saying.
Oh, I mean, is that of a big difference?
No, it's 3.2. That's all.
Instead of 3.8?
Correct.
Okay, let me take a look. So x equals 2 divided by tangent 32. So that is 3.2, but that's x. We did not determine a. You only determined x.
Oh, you were determining A.
So the question is asking us for A, not for X. So this is just X, which is 3.2 miles. So I stopped because I didn't want to go that route, but now since we're here, we have to find X. So now we have this. We have 3.2 here. We have Y, which is 2. So we're asked to find A. So now I will use the Pythagorean theorem if you want. It's the square root of 3.2 squared plus 2 squared. The answer has to be the same. So the square root of 3.2 squared. So in parentheses, 3.2 squared plus 4, close the parenthesis, and I have to get very, very close. And it's very close. It's 3.774 versus 3.7735. Good. Is this clear? Okay, perfect. Can we move back to 6 dot? Do we need more examples from maybe side-side angle, the ambiguous case, or?
Yes, can we
Okay.
do some side-side?
Yes, yes, very good.
We've got 2 triangles.
Yes, yes, of course. So let's hit a side-side angle. I'm assuming they are between 19 and 28. So 19 on 473. So let's choose. I don't remember what we chose last time. We can look it up. Let's try another one. And we'll see. If we don't hit side-side angle, then we can move on to another problem till we find one. I don't know the answers, so I can't tell you which one to pick. So, which one? Okay, let's try 22, and let's see what happens. So 22 on page 473. If it's not side-side angle, well, I have to graph it first. So angle ABC, B equals 45. Little c equals 42. And angle C is 38. It is a side-side angle. Here it is. Side in order, in any direction, it doesn't matter. Side angle. Side is given, and next side is given, and the next angle is given. If this angle is given, then we have side angle side, which is not the ambiguous case. Okay, perfect. So we're asked to solve this triangle. What do I write? What is the starting point?
So let's find.
No, I have to write law of sines before I find anything. Sine A divided by A equals,
Sine B divided by
exactly, divided by 45 equals,
sine 38
exactly.
divided by 42.
Good. Which proportion I will be using to find B? The last two indeed. So I cross multiply and divide by 42. So I have sine B equals 45 times sine 38 divided by 42. I put everything in the calculator at once, in one step. So let's do that. 45, because it's a product, I'm okay, it's safe. So sine 38 divided by 42. And I got 0.6596. Exactly. And I recommend use it on the whole thing. I don't really need you to write sine B if you don't want to, or you can approximate it, but apply sine inverse to the previous answer. You will have the tiniest error possible. So sine, so what does 41.3 mean? What is it?
So
Exactly.
Angle B.
Yes, I'm going to call it angle B1. 41.3 degrees. I'm going to look at the unit circle, and I would like to see if there is a B2. I don't know if there is a B2 or not. But what should B2 be? If this is 41.3 degrees at the same height with the same sine, I have to get this angle which starts, which is standard angle as well. So what will that angle be?
41.9.
The other way around. Exactly. Because the reference angle for both angles is, of course, we know that. So how much is it? 138.7 degrees. If I can determine, so I have B. If I can determine A, both are possible triangles. If I cannot determine A in either one, then only one triangle is possible. So let's determine an A1 and let's determine, oops, I meant an A2. And no one can change C. C is the same, 38 degrees in both triangles. So now, from 180, I subtract 41.3 and I subtract 38 degrees. And also from 180, I subtract 137 degrees and 38 degrees. Do I get A1 and A2? So from 180, please subtract 41.3 and subtract 38. What is the answer? 100.7. Okay, degrees. So now from 180, please subtract 38 and subtract 137.7. So A2 is 3.3 degrees. Therefore, we do have a situation with two triangles. Triangle number 1, triangle number 2. A1, 100.7. A2, 3.3. B1, 41.3. B2, 137.7. C1. No, I don't want to write 1 because it's only one C. Sorry about that. So it's C in both. C equals 38 in both. 38 degrees. I will have a A1. I will have an A2. But I do have a B, which is both the same. B is 45 in both. And a lowercase c, which is 42 in both. So the only other thing that I have to determine is letter A, I mean side A and side B. So I come back here. So here's where side A is. I will be using this, in which I write the sine A over A. But I do have A now, angle A. So I write sine 100.7 degrees divided by lowercase a1 equals sine 38 degrees over 42. And the other one will be sine 3.3 degrees, that's the other A, divided by lowercase a2 lowercase a2 equals 138 divided by 42. Sine 38 degrees over 42. So for me, I cross multiply, I get a1 and a2. So a1 equals this times this over this. 42 times sine 100.7 degrees over sine 38 degrees, and I'll come back and put in the graphing calculator, and a2 will be 42 times sine 3.3 degrees over over sine 38 degrees. Now I put those two in the calculator, and I'll have a1 and a2, little lowercase. So 42 sine 100.7 close divided by sine 38. So sine 38 degrees. And the other one, I just copy the entry and I will replace, everything is the same. All I have to do is replace 100.7 by 3.3. 3.3 and clear the rest. And press enter. So, lowercase a1 is 67, approximately 67. Lowercase a2 is approximately 4. So now I go back to my calculations, and I write here 67, and I write here 4. So I determined two triangles, I shouldn't say completely different, they still have some common elements, but they are two different triangles. And both triangles fulfill all conditions given in the problem. Because they have the same c, they have the same lowercase b, and they have the same lowercase c. This happens only in the ambiguous case. Only if I'm given a side, and an angle. All the other cases have two possibilities. The triangle exists or it does not. Yes, Chris?
I don't get A1, A2 again. For the
Lowercase?
no, the angle. Angle A.
The sum of the angles in any triangle has to be 180. So if I have B1, which is 41.3, and I have C, which is 38, I subtract these two from 180 to get that.
Oh.
So 180 minus 41.3 and minus 38 will give us A1. And 180 minus B2, which is 137.7, and minus 38 will give us A2. Better? Good. Other questions here? Other questions? Okay. Are we in the clear? Can we say that we understand law of sines and law of cosines and how to apply them? Yes? Okay. Good. So can we go back then to 6.4 and do more problems? So although we did all of them, I think, 6.4, we did all types of problems on page 468 at the top. We selected from each and every one of them. I'm ready to select anything else that you would like. I know you have 39 to work on, and you have the height of a balloon, 41. We can do one of those. We can go back and determine something from 33 through 36. So let's do that.